So in this video, we will see how to solve homogeneous nonlinear differential equation. We will use substitution method to solve this homogeneous nonlinear differential equation. To do that, let's define homogeneous function first. A function f of x comma y is called homogeneous function if it satisfies the following properties of the function f, and you replace the x by tx and y by ty. If you can simplify that into something like t to the alpha f of x comma y, so where this alpha is a real number. If a function that satisfies this property, we call that function a homogeneous function. Let me give you two examples, one a function that is homogeneous, one that is not homogeneous. Let's take a look at the example number 1. Let's take a look at this function, which is f of x comma y is very simple as the sum of the squares of both the variables x and y. Now if I replace the x by tx, if I replace the y by ty, you agree with me, my function would be the following. Okay, here I have a function in which the variables x and y are replaced by tx and ty. Now if I simplify, I'm going to have t squared x squared plus t squared y squared. And if I further simplify, you agree I'm going to have t squared of x squared plus y squared right here. Now that tells me this guy right here is exactly same as the function right there. So therefore I can replace that term by f of x comma y. So here you see, here this function satisfies the definition of the homogeneous function right here, because I have something like that, right? Here if you want to more precisely, we can say that t happens to be 2. That shows that the function f of x comma y equals x squared plus y squared is a homogeneous function. Now let's take a look at another example where that is not a homogeneous. Let's take a look at this function right here. F of x comma y equals x plus y squared, as simple as that. If you replace the x and y by tx and ty, you see that I'm going to have tx plus ty the whole squared, which if I simplify, all I can do is just that, and you see that this function right here is not equal to f of x comma y. So therefore f of tx ty cannot be written as t to the alpha f of x comma y, no matter the alpha is. That is the definition of a homogeneous function. Now we're going to use this definition to define a homogeneous differential equation. So what is the homogeneous differential equation? So we're going to use this definition of the homogeneous function to define the homogeneous nonlinear differential equation. Let's see how do we do that. So a differential equation which is of the form something like this, y prime equals f of x comma y, is called homogeneous differential equation if the function f right here, f of x comma y, happens to be a homogeneous function. Right? If that happens to be a homogeneous function, then this is the homogeneous differential equation. Let's see how do we solve this homogeneous differential equation. As I told you before, we are going to use a substitution to solve this homogeneous differential equation. So I'm going to give you 6 steps 1 through 6, to show how to solve this homogeneous differential equation. Step 1, simplify the differential equation in the form y prime equals f of x comma y. So step 2 is to identify and verify that this is indeed a homogeneous differential equation. Now step 3, so this is a very important step, the substitution. We're going to replace the variable y equals vx. This v is an unknown function right there. Now let's see how do we make use of this. Since it's an unknown function, if you simplify, we are going to have y prime would be v prime x plus v times 1, which is simply v. So we're going to take these guys. So we're going to take this and then we're going to substitute this back into our differential equation, and then we're going to solve there. The next step is separate the variables, and that is our variable separable method. Step 5 is to integrate as we did in the variable separable method, and step 6 is to simplify, resubstitute, and if need be simplify further. So that is our 6-step process in solving this homogeneous differential equation. So let me again repeat this. The very first step is to simplify. The second step is to identify and verify whether this is indeed a differential equation. Then the third step is to do a substitution, and then we separate the variables, and then we integrate, we simplify, resubstitute, and simplify if need be. And that's how we solve this homogeneous differential equation. So let's do an example in the next video.